Okay, so we are starting a new unit on right triangles. And you are going to be asked to simplify radicals, to leave your answers in simplified radical form. So because of that, we're going to do a review of radicals. Now, what is a radical? A radical essentially is an expression that has a root. It could be a square root. It can be a cube root. Our cue that it is a root is we'll have this radical symbol. Okay, so let's take a look at some of these numbers that we have up here. Why do we have some of these numbers up here? Well, these are our perfect squares. So we're all familiar with taking the square root of something. The square root of 64 is simply 8. Okay, so this is just 8. So here we've simplified our square root, our radical. Now we're going to look at some examples where our answer is not going to be just one number. Let's take a look at the square root of 50. Now this can be simplified two ways. The first way is by simply factoring these. Okay? So 50, we can break it down into anything that we want. We can break it down into 5 times 10. And then, as you guys remember from earlier years, we can break these down further. So this is still 5. So this reads as 5 times 10. 10 reads as 5 times 5, or 5 times 2 rather. So now I have 5 times 5 times 2. Okay? So I have all these perfect squares up here. One that I can see right now is 5 times 5, which is 25. So all of these are still square roots. So this reads as the square root of 25 times 2. The square root of 25 is just 5. So this is the square root of 25 times the square root of 2. The square root of 25 is 5. This is 5 root 2. Or what you can do is you can see that we have a pair of 5s. Here I'm going to circle my pair of 5. So 5, 5, square root 2. The shortcut here is after you see that there's a pair of 5s, you know that this can be whatever number you have, the square root of it will just be that number, because you have 2 of them. All right, let's take a look at some bigger examples. Take a look at the square root of 90. The square root of 90. So I can break these down into factors that I'm aware of. Up here are my perfect squares. Okay, another way of approaching this is by selecting your biggest perfect square, you will be able to speed up the process. So I know that out of these, 9 goes into 90. So I'm just going to select 9 and see how that goes. So I know 90 breaks down into 9 times 10. Square root of 9 times the square root of 10. All right, so let's break this down even more. This is 3 times 3. 9 is 3 times 3 times, and 10 is 5 times 2. All right, so the reason I've broken this down and what I've kept bringing these numbers down is because 3 times 3 times 5 times 2 is the same thing as 90. I need to bring all my numbers. So here I can see my pair of numbers is 3. So I have 3, and then the numbers that don't have a perfect square are 5 times 2, which is 10. Or another way of looking at it is this. Some of us may have already seen that, okay, the square root of 9 is 3. The square root of 10 can't be broken down. So the whole goal of simplifying radicals is pulling out perfect squares from our numbers. So in 50, the perfect square that I pulled out was 25. In 90, the perfect square that I pulled out was 3. Okay? So let's see one more example when we have some variables involved. Keep going. Find an eraser. So let's say we have the square root of 27. It's easy enough. But we're going to make it more complicated. We're going to add a cubed and b squared. Now the easiest way to approach this is by writing three different radicals. This is the square root of 27 times the square root of a cubed times the square root of b squared. Okay? Now each of these we can break down separately and at the end multiply them together and we'll have simplest radical form. So 27 breaks down into, let's see here, 4 doesn't go into it, 9 does. 9 times 3. Okay, this is just 3 times 3. And this is 3. So I have my pair of 3s. This is 3 square root 3. A breaks down into, or a cubed is a times a times a. So same thing before, all I need to do is circle the pair of numbers that I have. Here I have a pair of a's, and then one a left over. So times a square root a, b squared. So let's say b was 2, right?